Let's expand this screen. There we go, up and running. All right, so this is just an exploration. It's very early in the morning here. Haven't had my coffee. Haven't planned out what I'm gonna say. But I do know that it's an exercise that I'm hoping we can all learn something from. So I've drawn a bunch of circles here. Take a little trip down memory lane. I wonder who the first person was who drew a circle, planet Earth. Maybe it was an alien. Maybe somebody came down and gave it to us. But now that the circle's drawn, what can we say about it? Historically, what do you think? Somebody probably did. You can pause the video, think about that for 10 or 20 seconds. And I don't know, I got a feeling somebody drew a dot in the center. These are all freehand drawings. Obviously, a little rotator cuff problem here. All right. And so historically, what probably came next? Well, probably somebody said, what do we want to call this thing? Well, I think center is probably a good name for, the dots, and sure looks like we can connect the center to the outer part of the circle, which I guess has to be given a name. Wonder what name came up for the outer part of the circle. Maybe circumference. Okay, it'd be interesting to see why that name was chosen. CIR, well, CIR, it's got something to do with circle. So that's good. A fence, fencing in the, I'm being a little silly here. But how many radiuses do we see, or radii, or whatever, the plural, whatever way you want to say it's fine with me. Why don't we call it a unit circle? Or we just think about this radius as 1 unit of length. I guess then the next question is, how many of those fit around a circle? Folks started looking at that, I guess. So you can pause the video and think about that. Well, hope you come up with what folks came up with historically. Circumference equals 2 pi r. And we're calling r what? We're not measuring it. We're not taking out a ruler and talking inches or meters or anything else. We're just saying it's 1 unit long. So I guess we gotta figure out where to start measuring from. And if we're talking about how many fit around the circle, then we gotta find a place to start from. So we standardized our discussion here. So we're all talking about the same thing. Yeah. It would be nice if I had a piece of string right now. What do I have? Oh, I do actually. I have a cord over there. What do I have over here? I've got rags. I guess I'll go with the cord. Yeah, somebody wrapped it up. Somebody wrapped this cord up nicely. In fact, it almost looks like a circle. Yeah, whoa, I could unwrap it, and I guess if I unwrap this and keep unwrapping it, I get a straight line. Yeah, well, that's another discussion to be had soon. But let's use the board here to measure. How about this one? I think I can handle this one here. There's a radius length. Okay, it's about the pinch of the finger and the thumb. That's the 1 radius length. And I wonder how many of them fit around a circle. Well, where's a good place to start? Don't think any place is any different than any other on a circle, but mathematicians, folks who gave us this language, okay, let me make sure there's some writing here so I won't lose that, decided that we'll measure it from here. So I'm gonna take 1 radius length. I'm gonna wrap it around the circle. And it looks like it's about there. Yeah, so this radius length. Now let's try another circle. Let's try the big one. Yeah, you can see that. So the big one's got, that's a much bigger radius length, but we're still calling it a 1 unit. So I gotta come over here And I gotta wrap that around there, and it's around here. And then I compare the two and I go, you know what? They seem to hit about the same place. Yeah, one radius length. Wrapped around the circle, starting at 3 o'clock on the circle, but we'll call this 0 because, you know, that's a length. And if I don't travel any length, that's 0. But if I go here, then, well, then that's one radius length. Yeah. And I suppose I could maybe even put a coordinate system in here. You know, that mapping system helps in a lot of places. And so, oh, I noticed something. That's also a radius. And if it's a unit circle radius, then I guess I'm going up 1 unit. Vertically 1 unit. Oh, that's a radius length. Well, if I think of this as the origin, then the x distance here is -1. And the y distance here is -1. And the x distance over here is +1. And now I've got myself a little coordinate system because there is no height here. There is no width here. There is no height here. And there is no width here. I guess that's how you find values on the y-axis. You let x equal 0. And I guess if you want to find values on the x-axis, you let y equal 0. And those calculations we've been studying. Oh, this is all well and good. So where am I going with it? Well, what is this coordinate? Can you estimate that coordinate? Well, let's go over and let's estimate some coordinates on a better drawn circle with the help of Desmos. Okay, so Desmos drew a nice circle. And I guess right about here's the center. And we're going to put a coordinate system in. That's pretty good here. Wow. That's pretty good. Proud of myself here. And 1 radian is this length wrapped around the circle. And it sure looks like it maybe is, I don't know, maybe there. That distance, it's all approximating here. Yeah, and I want to know what that coordinate is now. How high is it? Well, if that's halfway up, that's 1. Now, what is that height? Well, we're going to estimate here in a little while. I guess if that's halfway, then that's 0.75. Your guess is as good as mine. But I suppose we could look at the radius length. Ah, you know what? Boy. That's, wow. It's about halfway over there. Wow, a little triangle. I mean, X, Y, right? X, Y. Ooh. Sure looks like it's close to a half. Close to a half. Close. You know, it's somewhere in here, right? And, oh yeah, you've been studying this topic. Oh yeah, you've been studying that. And, well, no, I can't say all of you have. I gotta be honest. Some of you haven't looked at it yet, because you're not getting it right on a test. It's been there for 3 weeks. The train's leaving the station. This is going to be a major topic here that we're starting to unravel. Unravel. Sorry, that was a little unwrapping joke for this unwrapping function. And this is, of course, a unit circle, so that's 1. And yeah, we have been studying Pythagorean relationship here. Those are the square areas associated with this right triangle. Should have put it over a little further, but I was afraid it would go off the wall. And yeah, you're trying to learn how to figure this out. Yeah, and I guess that's gotta be 3/4. 1/4 plus 3/4 equals 1. So I guess this length is the square root of 3/4. Which I believe could be more simply stated as the square root of 3/2. And I gave you a memorization sheet a month ago. And we certainly have been talking about the square root of 3 the past week. Well, some of you have been talking about it, some of you haven't. But I've been talking about it. Asking you to know the approximation, so you can pause the video now and see if you're one of the folks who actually knows the decimal approximation. I just keep saying it. It's approximately 1.73. And if you cut that in half, that's on the memorization sheet. I'm saying, hey, you ought to know that that's 0.87. Yeah. So I guess we're 1/2, 0.5, 0.87. We're in that terrain. We're in that territory. So I wonder where. Oh, we got to call this something, right? This is one radius length. Well, the textbooks tell us that's called a radian. That's a radian. And if we want to locate places on a circle, that's what we use for a measurement. And this is leading us obviously into the study of trigonometry. So knowing how to do this is extremely important. And we're going to be building off of this into major topics. And if you don't want to get lost, and you got a break coming up in 3 or 4 days, when you come back from that break, you've had 3 tests now. It's been on all of them. It's been on 17 worksheets. I strongly suggest you make sure you know how to do that before you come back. Stern warning. So 5 radius lengths. There you go. 5 radians. What's the coordinate? Get an approximation. Pause the video, think about it. 5 radians. I'm just going to keep talking. Obviously, radians also match up with angles. Right? I mean, if this is 0, if we're starting here, 0 radius lengths. Then it also acts as an angle. How many degrees in a circle? Said 360. So it's 360 degrees in a circle. And I guess the next question is, how many radius lengths are there in a circle? We talked about that a little while ago. Circumference equals 2 pi r. And what's our radius length? Unit circle of 1 radian. And that's going to match up with a certain number of degrees. Okay. I actually gave you a 60-degree triangle here. These are exact values for a 60-degree triangle. 1/2 √3/2. Okay. And there's a video on the channel, introduction to the unit circle. And it introduces the drawings that go with 60-degree triangle. I might as well do it, because you might not see that other video. That takes effort to see those videos. Start with an equilateral triangle. Just hope that that's a 1, 1, 1. You drop a perpendicular. If you do, you've got the triangle we did a moment ago. 1/2 √3/2, 1, and this is 60 degrees, obviously, right? Equilateral triangle, 60 degrees, 60 degrees, 60 degrees. They're all 60. So when I cut this in half, that's 30 degrees. And the famous ratios of the 30, 60, 90-degree triangle are 1/2 √3/2. Sometimes it's the width, sometimes it's the height. All right, so what's 60 degrees? Well, we're back over to the unit circle. Two pi r. And if the radius is 1, then it's 2 pi radius lengths to go all the way around. And what is 2 pi radius lengths? Roughly 6.28 radius length. And I'm not going to say radius lengths anymore. I'm going to say radians. Because the word radius has been reserved for the center to the circumference. Radius length is measured from over here. There is no length. And then if we travel one radius length, turns out that's about 57.3 degrees. Okay. So what's 60 degrees? Well, if 360 degrees is 2 pi, that's exact, right? 2 pi times 1. Different language system now, and this is the language system that trigonometry is built on. So we're going to have to learn to speak in 2 languages, which is why we're starting with this video, beginning that conversation. Then there's 6.28 radius lengths all the way around the circle. And how does 60 degrees compare to 360? It's 6 parts, yes? 6 times 60, 360. And that can be reduced. 2 pi over 6 is pi over 3. So there's an equivalent language system. And what is pi over 3? It is 3.14 approximately divided by 3. So 60 degrees is about 1.04-ish. Maybe it's closer to say 1.05. Radius lengths takes us to a place on the circle, which takes us to a coordinate, which eventually is going to take us to the ability to do something like the following. And we got a lot of work to do to get here. These are called sinusoids. What happens when you talk about height? Let's do a quick height. I could do width as well, but I think it's easier for you to see height. As my finger goes around the circumference of the circle, I'm just going to trace the pattern I made. Okay? Sometimes we have a maximum height. Then when we get down here, half a rotation, a minimum height. So I'll just do one real quick. Let's say that y equals 50. Let's go up to a height of 60 here. Let's call that the number. Oh, I want to give it some values. So let's give it 90 units of something. And over here, let's say that that goes down to 20, let's see, it's 50, 40, it's got to be 10 units. Okay, and let's say this happened in 2024. There's 90 or something. 50 years later, no, I don't want that because you're seeing that number. Let's call it 237. Right, maybe that's a funky enough number that we can work with it easily. Let's call this 227. No, let's keep it 224. All right, I'm just going to write the equation. So this equation is y equals 50 plus, I got a choice. I'll do a sine function. I think it'll be easier for you to understand. And I'm going to write x minus 2024. I'm going to talk about pi over 2, which is the top half of the circle. All right. Cut up into 4 parts. You're not going to understand what I'm doing anyway, so I'll just write it. So 1, 2, 3, 4, 5 pi. That's 2.5 revolutions. Happens in 2024 to 13 years. All right. I don't like 13. I'm going to go 14. 13 is an unlucky number for me. There we go. That's what I was wearing when I got the knee blown out. So there we go. 50, 90, 10. That's the equation, right? And just you can write those just as quick as you write the equation of a line, but only if you learn those parts of the process. And the process has to start somewhere. So we started somewhere. We started over here, right there. We actually started by drawing a circle, learning that somebody called it the center, and the distance to the outside is a radius length. And that radius length, how many of them go around? Circumference divided by diameter. But circumference divided by diameter, the actual value of pi. So a diameter, 3 times 3.14 of these is the distance around that circle. All right, and one concept builds to another. And if you're not getting this Pythagorean relationship down, you're not going to be ready for the next discussion we have. Okay, and try to plant some seeds here. Plant some seeds. So estimate one last time. Let's estimate, I think I asked 5. All right, so we got to go estimate 5 radians. I think I asked the question, but I don't think I ever did it. Okay, so I'm going to do it for you. Well, I know how many radians it takes to get over here. 3.14. 3.14 of these radius lengths. 1, 2, 3.14. Take me halfway around the circle. So 1.57-ish radius lengths takes me here. There's 1 and a little bit more than a half of 1. Takes me to there. So tripling this, 1 chunk, 2 chunks, 3 chunks takes me to here. 3 times this, 1, 5, 6. Okay, I gotta do this. It's too early in the morning for my brain. 1, 2, 15, 17, excuse me. So 4.71. 4.71 radius lengths. 1, 2, 3, 3.14, 4.17, and finally 6.28 radius lengths. That's traveling around the circumference of the circle. That's what we're going to be doing. And so where's 5? Well, 6.28, 4.71. I'm saying it's right about there. Drawing a triangle. Oh, the x distance seems to be about 0.25. I don't know how close these things are until I define the trig functions and then do it in a calculator. But I'm just getting a sense of what a radian is because students tend not to know. And if you don't know, you don't know trigonometry. So I don't know, maybe negative 0.94 units. I mean, this is, yeah, they go all the way down to -1 vertically. So what is that? Your guess is as good as mine. I can certainly find it. If I want the x coordinate, then I do this mathematical operation saying the cosine of 5. Make sure I'm in radians. The sine of 5. Should already be thinking cosine is dealing with the x value and sine is dealing with the y value. We're going to define those functions. We're going to show you how to get those answers. Some of them without a calculator, most with. And so that we're up and running with that discussion. And we got one more huge discussion. One more huge discussion that you need to know how to write the equation. You know, you got a constant here, K for constant. Yep. My grandson would say C constant, C-O-N-S-T-A-N-T. But no, it's K. It's constant. Yep. And 2 points. And writing that equation as quick as you write the equation of a line. And you know, a lot of youngsters do that. Earlier grade levels because they put the time in to learn the mechanics. It's number mapping. You know, how do you get from 7 to 10? You know, you go up 3. It's the same thing. It's just some number mapping. It takes, you know, takes practice. And if you're not looking at it, well, you can't get it done. And if you don't know how to do this, then you're going to miss out on a major topic that we're going to start talking about when you get back from break. So you might want to, over the break, get that done before you come back. Figure out how to do it. There's plenty of practice out there. Videos, there's probably 30 or 40 practice problems in the videos. So good luck with that. See you in class. Ta-ta.